Hi, my name is Amar, and welcome to the Software Bill of Materials demo. Before we get into the demo, let's talk about what's going on in the industry and how we can help. So number one, if you look at the current state of the industry, what you realize is you have this medical device on the left where the current machine state is not available, right? So you have a fleet of these devices in the field and you don't know what version they are at, where they're at, and things like that. The cybersecurity software bill of materials, therefore, by definition, is not available because we don't have a full known state of all devices. And therefore, there are no audit capabilities. A lot of the times, the security attacks on the device are unknown and unreported. The machine is essentially a black box. And if you look at it from an HDO's perspective, the IT folks in the HDO are trying to guess the state. And the very fact that we're guessing and we are using tools to guess the state could leave the device in an unwanted state, right, or an inoperational state. So how does a software bill of material enable better outcome? So first, let's get the machine state locally. We can do that in two ways. One is authenticated scans. To do an authenticated scan, the HDO needs the administrative credentials to get detailed and accurate information. The authenticated scan needs to be scheduled so the device is not being used, and therefore it has to be taken out of operation mode. However, the MDMs are usually unwilling to share that credential because once the credentials are shared, inadvertently, the validated state of that machine could be changed without their knowledge. A lot of the times, MDMs have one administrative credential per model, and therefore, if they gave out that credential, that means their whole fleet of devices could get affected if that credentials were ever to get into the wrong hands. And once again, this could leave the machine in an unwanted state, which is not ideal for an MDM or the HDO for that matter. So the Software Bill of Materials API, there's a clear way to get a SBOM or Software Bill of Material from the device. This could be done through an API key, which could be time-bound, it could be one-time and device-specific. The device, because the API is being used, knows that an action is being requested. The device could take appropriate actions or appropriate steps, pre-action before the API is run, post-action after it's finished running the API, and during error conditions. And anytime a bad API key is given, the device can actually deploy countermeasures. So the API sounds like a pretty big step above and beyond the authenticated scan. Now we could go one step further where we say, let's get the machine state from the cloud as opposed to the device itself. And what this gives us in terms of advantages is the device is constantly in lockdown mode by default, right? It's reporting the state and the security events to a cloud, and this cloud could be remote or it could be on premises. There's self-sensing and self-protection. Because the device is not expecting anyone to probe it or reach out to it, it can basically easily now detect attacks and it can deploy countermeasures to reduce the attack surface. And lastly, the device can actually take some self-healing measures. It can monitor its own current state, and if that current state is ever altered, it could actually make self-repairs upon that error detection. So you get a device which is self-sensing, self-protecting, and self-healing. Now on the cloud side, you get a few more advantages as well. So we now have very specific and definite APIs for getting device state and security event logs. The state requests need an API key. Once again, that API key can be time-bound, it can be location-specific, it can be service-specific. And every time someone uses that API key to get a state, the audit log of that request can be saved. And that audit log can once again periodically be reviewed to make sure that no one's abusing that API, right? That API is not gotten out of hand or the wrong person hasn't gotten it. So once again, we have advantages both on the device side and on the cloud side. So let's look at a quick demo of this now. So here on my web console, what I have is I have a list of devices. Most of them just have serial numbers. We haven't really added device names and things like that. to most of them. But let's assume that one of the devices is in a hospital. It's on a second floor. So we can start searching for second floor. We found our device. Now we can basically say, I want to download the bill of material, or I can view the bill of material live. So let's actually start with the viewing of the bill of material. And what you now have is you have a list of particular components that are found in this particular device. And you can see the list has a name, it has a version number, it has an architecture, and it has dependencies. And you can go down the dependency tree, and you can actually start seeing any sub-dependencies that basically that package may have. So it gives us a pretty good way to drill down into the devices and see what that device has. Now, the advantages of doing that is all of a sudden now I can check, I know all my components on there. If a particular component was found to have an issue, I can very quickly search for it. So in this case, I'm going to search for ACL, which we know it's at the very top, and I can very quickly see that these three ACL type of components are installed on it. I can check the version, and I can compare that against an NVD database to see what are the vulnerabilities against that version. And on that vulnerability, then I can actually do a risk assessment, right? For each and every vulnerability, does that affect me or does that not affect me? Are there some mitigations around that? So you can not only look at your current state, but you can actually try to figure out what a future state looks like. If I try to take this particular version from say 2.2.52 to say 2.2 to 2.60, once again, if I try to make that upgrade, what type of effect am I going to see, right? You can do this what if scenarios. And once again, these particular components, right, and this device tree lives in the cloud. So once again, these APIs to search for this can be web-based, i.e. there is a user interface, or it can be automated, i.e. through an API, someone can pull this information, which can then be correlated and collated with the NVD database and other enterprise level tools. So once again, thank you for watching this video, and hopefully this shows you how a software bill of materials can be stored in a cloud when the device is sending that data to the cloud. Once again, thank you.